Hello guys, in this video I am going to give you the solution of this question number 12 of chapter 9 of the book Engineering Circuit Analysis by Hayt, Kemmerly and Irving. So the question says that for this circuit 9.38 we need to obtain an expression for VCT, means the voltage across this capacitor, for valid for all t greater than 0. So to solve this, first of all we need to check the condition of the circuit at t less than 0 and t greater than 0. So if we talk about t less than 0, at t less than 0 we know that when we assume that t less than 0, we assume that the circuit is in this state for longer time. So for longer time means that the inductor will be replaced with the short circuit and capacitor will be replaced with the open circuit. So for the t less than 0, our circuit, it will look something like this. Resistor will remain as it is, right? And at t equal to 0, this switch is closed. So t less than 0, the switch is open. So this switch is open. Now the inductor, it will be replaced with a short circuit. This capacitor, it will be replaced with open circuit. And then this R, it is 0.1 ohm. This is VC. This is IL. This is 20K. This is 6 volt, right? This is IR. And this is this circuit at t less than 0, right? If we try to get the circuit for t greater than 0, then our circuit, it will be something like this. At t greater than 0, again 20k ohm, this is plus minus 6 volt, and this switch is closed. It is closed at t greater than 0, equal to and greater than 0. So this switch, it will be something like this. And then we have also the inductor over here. We have the capacitor, and we also have the resistor. So our circuit will look something like this. Over here the inductor, it is 2 by 13 H. This is IL. This is IC. This is 250 microfarad. This is plus minus VC, and this is 0.1 ohm, and this is IR, and this is the circuit at t greater than 0, right? Now from the t less than 0, from t less than 0, if we look at t less than 0, then you can see that this circuit is connected, just this part of the circuit, it is connected, right? So it is simply all the elements are connected in series, and the two elements, we have two elements, 20k resistor and 1.1 ohm resistor, and we have one voltage source. So with this we can determine the value of IR. This current IR, it will be total voltage, which is 6 upon total resistance, which is 20k plus 0.1. Now since 0.1, it is very less in comparison to 20k, so we can write this, or we can say that IR, it is equals to 6 by 20, just a minute. 6 by 20. Yes. So 6 by 20, and so 6 by 20 milliampere, or we can say that it is like this 10, this 3, so we can simply say that it is 0.3 milliampere. So our IR, it is equals to this, and since IR is this, so if you look at IL, now as per this IR current will be flowing in this direction, whereas the direction of IL is opposite. So IL will be equals to minus IR, which is equals to minus 3 milliampere. So this is the current that is flowing through this inductor, right? Or we can say that at 0 minus, the current flowing through the inductor, it is this. So this is our first initial condition. Now similar to this, if we want to determine the voltage across the capacitor, now before t less than 0, or at t equals to 0 minus, so the voltage across this capacitor, it will be the voltage drop across this 0.1 ohm, right? 0.1 ohm. So VC 0 minus, it will be 0.1 into current is IR, so it is 0.1 into, and one more thing over here, yes, it is good, it is okay, yes, so it is IR is 0.3 milliampere, so it will be our VC 0 minus, it will be this 0.1 into 0.3, it is 0.3 millivolt. So this is our initial condition. We get the two initial conditions with this. Now coming to this circuit, t greater than 0. Now for this circuit, if you look at this part, now over here it is short circuited over here, and since it is short circuited, so if just a minute, yes, so if this current is I1, then I1 current will flow over here, and the complete current will flow over here I1, and it will return over here. Means what I am trying to say, that since it is short circuited over here, so there all the current will all the current from this 6 volt, it will flow only in this loop, and there will not be any current in this part of the circuit. Because of this 6 volt, there will not be any current flowing through in this part of the circuit. So due to this, we can remove this part from this part of the circuit. So we can redraw this something like this. And this (250 millifarad), it is 2 by 13 H, and this is 0.19 ohm, right? So we can redraw this circuit in this form, and we separate these two circuit into two parts because of this short circuit. Because of this short circuit, there all the current, because of this 6 volt, all the current will flow only within this loop, and no current will come to this part of the circuit. So since we need to, so it means, since we need, as per the question, what we need to determine, we need to determine the expression for VCT, and since in this part of the question, the contribution due to this, it is nil. The contribution of this part in the voltage across the capacitor, resistor or the inductor, it is contribution is 0. So we can remove this part of the circuit. So it means overall our circuit, we need to analyze only this part of the circuit, right? And this part, if you look at this is simply our parallel RLC circuit. And since it is parallel RLC circuit, so it means we will apply the rules of the parallel RLC circuit, means we will apply all the formulas related to parallel RLC circuit. So applying the rules, first of all we determine the alpha. Alpha formula is 1 upon 2 RC. If you substitute the value of R as 0.1, C it is 250 millifarad. This 250 millifarad. So 250 into 10 power minus 3. So you will get alpha as 20 radians per second. Similarly, omega 1 upon root LC. If you substitute the value over here, so you will get 2 by 13 into 250 into 10 power minus 3. So if you solve this, so you will get the answer as 26 root 26 radian per second. Now over here you can see that alpha is greater than omega naught. This 20 is greater than root 26. So it implies that our circuit response, it will be overdamped response. It will be overdamped response. And for the overdamped response, we know that the voltage equation, this node voltage, the voltage at the node voltage or at the node, or if it is V, it means that the voltage across all this element is also V, because in parallel circuit voltages are same, right? So this VT for the overdamped response, this VT, it is given as A1 e power S1t plus A2 e power S2t, right? So means we need to determine S1 and S2. So to determine the S1 and S2, so this is our equation. So to determine S1 and S2, the formula is minus alpha plus minus alpha square minus omega naught square, right? Now substituting the value of this alpha and this omega naught, you will get S1 and S2 minus 39.34 and minus 0.66, right? Substituting this value in this equation, we get Vt is equals to A1 e power minus 39.34 t plus A2 e power minus 0.66 t, right? Now over here we need to determine the constants A1 and A2 constant. These constants we will determine using the initial conditions. What are the initial conditions? These are the initial conditions. So first we can substitute, like we know that this V voltage at 0 minus, it is 0.03. And remember, the voltage across the capacitor, the voltage across the capacitor at 0 minus, same will be there at 0 plus also, because capacitor tried not to change the voltage. So at 0 plus the voltage will be 0.03. Similarly for the inductor tried not to change the current, so the current at 0 plus, it will remain same whatever is at 0 minus. So it is this. So taking this as the initial condition, first of all this capacitor, so we can substitute this value, it is 0.03, 0.03, and just a minute, 0.03 equals to a1. So this term, it will become 1 when we substitute t equals to 0. So this term, it will become 1. So we will keep it as it is, and plus a2. So our this is our first equation, right? And remember, it is over here, this is milliampere. So instead of this, we will write 10 power minus 3. We will add this also. So indirectly, or we can write it as a1 plus a2 is equals to 0.03 into 10 power minus 3. So this is our first equation. Now to get the second equation, what we can do, we know that it is a voltage across the capacitor, inductor, as well as across the resistor, right? So we will, and from this like this is our IL, this is our IC, and this is our IR, right? So it means applying the current KCL, at this node, we will get IL plus IC plus IR is equals to 0. So we can, for the initial condition, it will be 0 plus IC 0 plus IR 0 plus equal to 0, right? Now IL 0 plus, we know what is it is. IL, this is IL, right? Because IL, it is IL 0 minus, it is minus 0.3. So it is IL. So IL 0 plus, it is minus 0.3. So I will substitute this value over here. So zero plus, for this it is IL 0 plus, it is minus 0.3 milliampere, right? Milliampere plus IC 0 plus, this I do not know. And what about this? Now IR 0 plus, it can be determined using this, because we know that the voltage across all the elements are same, right? So if whatever is the voltage across the capacitor, the same voltage will be there across the resistor also, and that voltage divided by resistance will give you the current, right? And we know from the initial condition, we know what is this V0 plus, it is 0.03 millivolt. So substituting this value, we will get 0.03 upon R is 0.1, so it is 0.3 milliampere, because it is millivolt, right? So our R is this. So substituting this value, we get, substituting this value over here, so it will be plus 0.3 milliampere, right? 0.3 milliampere. So just a minute, I guess I did a little bit mistake. Just a minute. IL is this. I see. It's this. Okay. So I see. minus 3. IL is okay, right? IL, L0 minus is minus IR, it is VC, so it is same 0 plus we can see, okay, so it is going to, you can see it is going to cancel. So our IC0, IC current through the capacitor, it is 0, it is 0, right? So now this is going to be our initial condition that we are going to use. Now we know, we got this value, we know that the current through the capacitor, it is expressed as this, right? So we will differentiate this equation. So we will get minus 39.34 A1 e power minus 39.34 t minus, we will differentiate this second term, it is minus 0.66 A2 e power minus 0.66 t, right? Now substituting like IC at 0 plus, we determined that it is 0, it is 0. So if it is 0, so we will put 0 equals to C, and then at t equals to 0, this terms, it will become 1. So we will get minus 39.34 A1 plus minus 0.66 A2, it is equals to 0, right? So, or we can write it as, this C will be cancelled because it is 0. So simply minus 39.34 A1 minus 0.66 A2, it is equals to 0. Or simply A1 is equals to, or A2 it is equals to minus 39.34 A1 upon 0.66. So this is our second equation. So we have now we have these two equations. First is this, second is this. So substituting this second in 1, we will get, 1 is A1 plus A2 is equals to 0.03 into 10 power minus 3. Now A2 is this. So substituting this value, we get AM minus 39.34 upon 0.66 A1 equals to 0.03 into 10 power minus 3. So A1, and it is 1 minus A1. So we will get 0.66 minus 39.34 upon 0.66 equals to 0.03 into 10 power minus 3. So with this, we will get A1, we will get the value of A1 as 0.03 into 10 power minus 3 into 0.66 upon, let me calculate, it is 39.34 minus 38.66. So it is minus 38.68. So solving this value, we will get 0.03 into 0.66 divided by 38.68. So A1, we will get A1 as 0-0.512 into 10 power minus 6. So this is A1. And once we get A1, we can get A2 using this formula. So our A2, it will be, A2 is minus 39.34 upon 0.66 A1. So A1 we have determined, so we will simply get 39.34 divided by 0.66. So we will get the value of A2 as 30.512 into 10 power minus 6. Let me check it once again. Just 39.34 divided by 0.66 into 0.512. So it is this. So it is this. So we get A1 and A2 as this. Substituting this A1 and A2 in this equation, we will get the answer. So our VT, it will be A1, so minus 0.512 into 10 power minus 6 e power minus 39.34t plus A2 30.512 into 10 power minus 6 e power minus 0.66t. So this 10 power minus 6, it is volt. So 10 power minus 6 can be taken as common to get the value as VT minus 0.512 e power minus 39.34t plus 30.512 e power minus 0.66t microvolt. So this is the voltage across all the three elements of the circuit. So coming back to the question says we need to obtain an expression for VCT valid, so voltage across the capacitor. So it is the answer. Just a minute. Yes, so this is the answer. So with this I end this video. If you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.